Hello everyone, today I'm going to talk about pulsar-based space navigation, which is currently being tested in connection with the NICU instrument on the International Space Station. But first I would like to make an announcement. Tomorrow, or as this video uploads in about 12 hours or so, depending on how fast it uploads, a Soyuz will launch the Soyuz MS-05 capsule with ISS Expedition 52. Of course, as it is a human carrying flight, I am extra excited for this, and I will live stream the launch. One of the astronauts is an ESA astronaut, and you can watch more about him and his mission on ESA's channel. Now to the topic, which is pulsar-based space navigation. First of all, pulsars are very dense spinning stars with a rotational period of, depending on the type of pulsar, between 1 and 10 seconds, or some pulsars rotate much faster at a few millisecond pulses. And what gives them their name is that they seem to pulse. That is because their properties, their magnetic field is not aligned with their rotational axis, so the rotational field as such actually spins, and if you measure the radiation coming from these stars, you can notice them pulsing as the axis of the magnetic field essentially points closer to the observer or further away from the observer very quickly. Now I might talk further about the astronomy and astrophysics behind how pulsars work and how they come to be, if you're interested, but for now this is all we need for the applicational part, for the navigation part. What this gives us is essentially a timer in outer space. And the way pulsar navigation works is that you have, of course, a data bank or some sort of file on your spacecraft where you have information about different pulsars and an instrument to actually observe them. And then you can use them as timers, and the actual navigation technique works basically like GPS or other navigational satellites. You have several sources that give you a relatively precise timing output, and these sources are at different locations and different directions, and the timing output from these sources is transmitted to you at the speed of light. And depending on your position, this speed of light adds a different amount of lag depending on how far away you are from that source. And so if you have several sources, if you have 4 or more sources for more precision, or 3 or more sources and a precise timer of your own, you can triangulate your position and the actual current time. Now, GPS satellites or other navigation satellites of course have a lot of advantages of their own. That's why we use them. They give a very precise timing pulse. Of course, the precision of timing in a pulsar depends on what kind of pulsar you're observing and what kind of instruments you're using and how well you can analyze that data. But GPS satellites can very easily give you an exact nanosecond time stamp. They just send the information right to you, and it's precise to the nanosecond, whereas in a pulsar you'll have a millisecond kind of precision, and then with further data analysis you might get a better precision, but it's, at least at this state of technology, much less precise. Also, of course, navigational satellites are designed to have signals that are very easy to recognize and very easy to pick up. And at least for use on Earth, the instruments to pick up navigational satellites are much simpler. But pulsars also have a lot of advantages, which is why they're being researched right now and why the navigation technique is being tested right now. Now there are of course a few hypothetical military advantages, like obviously you don't have to worry that a pulsar will be taken out by an anti-satellite missile anytime soon, but much more interestingly, at least I think it's much more interesting, is the application for deep space travel and deep space navigation. To start with, the obvious, navigation satellites are of course designed to be easily received on Earth. They are essentially pointed towards Earth. Of course, there are different, very complicated antenna designs that are made to cover different parts of the Earth, but generally they are pointed towards Earth. Their signal is only that strong, and you would need quite a bit of instruments to pick up a satellite from far away in deep space when that satellite isn't even really transmitting into space but pointed towards Earth, and you're only picking up tiny bits of escaping signal. Now, of course, there are ground stations and satellites available for space navigation as well that will send to spacecraft when needed, but there are a few more problems with using satellites for space navigation. One of them simply being geometry and distance. Most navigational satellites are in Earth orbit, in geostationary orbit to be precise, and the precision of triangulation is dependent on several things. It doesn't only depend on how precise you can tell the distance to a satellite. Of course, using precise timer and using a signal coming from Earth, you will always be able to tell your distance from Earth very precisely, or your distance from an Earth orbiting satellite very precisely, but to also tell your direction from Earth, you will need to tell the difference in distance from different Earth-based satellites, and according to the laws of trigonometry and geometry, this will get less precise the further away you are relative to the distance between these satellites. So, for example, as these satellites are only in geostationary orbit, if you are much further away than the Moon's orbit, your positioning in terms of direction from Earth becomes much less precise, as you can imagine it like two levers essentially. If your information on the different distances from the different satellites is a little bit imprecise, that leads to a much bigger imprecision in your information in terms of direction relative to Earth. Of course, you can fix that by using an additional navigation system, for example by using the stars to orientate yourself and then looking at the Earth with an actual telescope and seeing in which direction it is relative to you, but that would require additional instruments. Of course, a small disadvantage that pulsar navigation has is that it essentially needs to be calibrated, as pulsars don't give a complete timestamp but only a periodic pattern that can be used to derive the timing. So essentially, if you are a lot closer or a lot further away from pulsars than you think you are, you might get a wrong distance, since you can measure the point within a period but not which exact period you are in. Of course, different pulsars can be used to find that out, or more precise measurements and more knowledge about that specific pulsar. And of course, a less precise navigational method could be used to calibrate this, so you know at least roughly which period you are actually in, so we can then measure where within that period you are. So you might need more than 4 pulsars to reliably navigate. Of course, this is less of a problem if your navigation is running continuously, so you basically have your navigation system running from the moment you launch from Earth to the end of mission. Then you can always count through the periods. But if you have a spacecraft hibernate, for example, and then turn off the navigation system and turn it on a lot later, you might no longer exactly know which period of a pulsar signal you are in right now. For now, pulsar-based navigation is in a research and experimental phase. There are two main notable projects on this. One is the Sextant project of NASA, which is currently being tested on the ISS in connection with the NICER instrument, and the other being the XP-NAV experimental satellite launched by China. Currently, the precision of pulsar-based navigation is within several kilometers of range, which is actually not that bad for real deep space navigation, but of course it can't compete with on-Earth GPS, and it's not really precise enough for every maneuver. You shouldn't land with an altimeter that is imprecise by several kilometers. But it's still in development, it's still in research, and depending on how well you analyze the signals coming from pulsars, it might still improve a lot. So for now, this was my introduction to pulsar-based navigation. I hope you found this kind of interesting. I'm always open for questions, and thanks for watching.